Welcome to aminacademy.com. In fluid mechanics, let us discuss about total pressure and center of pressure. Total pressure is defined as the force exerted by a static fluid on a surface, either plane or curved, when the fluid comes in contact with the surfaces. This force always acts normal to the surface. Center of pressure is defined as the point of application of the total pressure on the surface. Now, let us discuss about total pressure and center of pressure of vertical plane submerged in liquid. Here, this is a plate having surface area A and it is submerged inside the liquid vertically. Then we'll calculate total pressure and center of pressure of this liquid due to static contact of liquid. Now consider this plate A, area of the surface, h bar is distance of CG, center of gravity from free surface, distance of CG from free surface of the liquid. That means here this is a point G from is h bar, then P is the point of center of pressure, then G center of gravity, P equal center of pressure, h dash equal distance of center of pressure. This is a point P from the free surface. This is a h dash, distance of center of pressure from free surface of the liquid. Now first we'll calculate total pressure. Now here consider a small strip of width dh, and width is b. Therefore, now consider pressure intensity on the strip. Pressure intensity of the strip equal P equal rho G H. Rho is the density of a liquid which is immersed. The plate is immersed on that liquid. Gravity and H. Now area of the strip, area of strip equal to delta A, which is equal B into dH. The small strip B dH. B into dH. Therefore, total pressure force on a strip equal dF is pressure intensity P into delta A. Here the total pressure on a strip is pressure intensity on the strip into area of that strip, which is equal, therefore dF we can write this one as rho GH plus BDH into rho GH into BDH. Now total pressure on the whole surface Here total pressure on this strip is rho GH BDH. If you want to find the total pressure complete surface, we have to integrate this. Equal, put F equal integral dF equal integral rho GH BDH, which is equal, here rho G is a constant integral and BH DH, but integral BH DH equal H and BDH is delta A. Here BDH is the delta A now, therefore, but BH DH equal HDA. Here H means the height, dA is area, therefore which is equal moment of, this is a moment of surface area about the free surface of liquid. Equal A into H bar. Here this moment is A into H bar. So this total area into H bar is the moment of the surface. Therefore, we can write the force, total force. Here force is rho G integral BH/DH, therefore which is equal rho G A H bar. Suppose it's 1, we can write from 1. This is 2. Rho G H bar. Here, this is a total pressure force on a surface is rho G A H bar. Here for water, we know that rho is 1000, G is 9.8, that the force will be in Newton. Therefore, it is in Newton. Force will be in Newton. Now, there is a now we will calculate center of pressure. Next is center of pressure. Now center of pressure, that is H days, will calculate. The moment of force F acting at P the moment of force F acting at P at a distance H days is equal F into H days. But moment of dF, that means here moment of this strip, now moment of the strip with H distance, moment of force dF acting on a strip about free surface of liquid, about a free surface of liquid is equal dF into H. Already we have dF is rho GH, rho GH BDH, rho GH into area is BDH into H. Now, therefore, sum of moment of all forces, sum of moment of all such forces about free surface is integrating surface of liquid is integrating the above expression rho GH into BDH into H, which is equal rho G is a constant, B into H into H dH equal rho G integral B H squared dH and B H squared dH, which write here further rho G H squared B dH, which is equal rho G H squared dA. But integral h squared dA equal b h squared dh. h squared dA is integral b h squared dh. This is equal moment of inertia of the surface about free surface of liquid, about free surface of liquid. Therefore we can say which is equal I0. We can write that means through CG I0, that this H expression integral of h squared dA is moment of inertia of the surface about the free surface. Suppose it is 3. Therefore sum of moments moments about free surface is equal rho g I0 from 3. Rho g I0, that from 3 here. Therefore now h bar, this look here, h bar into P, that is moment about this some particular point P, that is moment of this surface area about the point P to the free surface is we have F into H dash equal rho g I0. But we know that, but F is equal rho g A H bar already we got. Therefore we have to write both sides. Instead of F we are writing rho g A H bar into H dash equal rho g I0. Therefore H dash equal rho g I0 over rho g A H bar. So rho g cut both sides, which is equal I0 over A H bar. This H dash by, this is through CG of the plate, but by theorem of parallel axis, we have, that means theorem of parallel axis means from the, this is from G, through G we have, from then we have to find moment of inertia through G we have, but we have to find through free surface. That is called parallax theorem we are using here is that is I0 equal Ig moment of inertia through center of gravity plus A into h bar square. That means here we got h days we are having h days is we got h day is equal to I0 by A h bar. Then from that we have to use it Ig equal to I0 equal to Ig plus AH square, this AH square bar. From that, therefore H days equal, we can write Ig plus AH bar square over AH equal Ig over AH bar plus H bar. Therefore, we are writing distance from the center of pressure from free surface, that is h days, equal Ig center of gravity moment of inertia through through Cg over A h bar plus h bar. We have where h bar is the distance of Cg. H bar here, h bar is the distance of Cg of the that plate which is immersed. H days is distance of center of pressure from through free surface. We have done. Please subscribe our YouTube channel.